So chapter 10, which is about the metals and extraction. The subtopic first we'll start with the properties of the metal. So these are the learning objectives, the general physical properties of the metal. So metals, they have a giant lattice structure of a positive ion in the free or the delocalized electron. So whenever we draw the structure of the metal, how we draw? We draw a lattice of a positive ion, means the regular arrangement of the positive ion is there. And the delocalized electrons. What is the meaning of delocalized electrons? Means electrons are free to move in these structures. So how to represent the delocalized electrons? We can represent by these lines, and it should not be in a specific direction because they are moving randomly. So the general properties of the metal, the structure of a metal consists of a lattice of a positive ion and the delocalized electron. So therefore, most of the metal have high melting point and high boiling point. What is the reason? Because metallic bond is strong. What is a metallic bond? Actually, the metallic bond is the attraction between the positive ion and the electron. So when the attraction is there between the positive ion and electron, what we call this attraction? We call this attraction as a metallic bond. And this metallic bond is very strong. That's why you will find when you have metal, usually, like exception for mercury, except for mercury, most of these metals have a high melting or boiling point. And these metals can conduct electricity. Why they can conduct electricity? Because they have a delocalized electron, so that electron can actually move from one place to another, and that is responsible for conduction of electricity. Then metals are malleable. What is the difference here, like malleable and brittle? Malleable means, look, the layers can slide over each other without breaking. Like when we say graphite, graphite is not malleable. Why graphite is not malleable? Because in case of graphite, the layers can slide, but the layers can break from each other. So graphite is not a malleable material. But what happens for metal, when we apply the force on the metal, the layer of the positive ion can slide over each other, can move from one place to another. And as these layers move, like example, if I draw two layers, say the first layer I'm representing by red, and the second layer I'm representing by blue. So when we apply the force, when we hammer, so as the result of this hammering, what happened? The layers slide over each other. One layer move over the other. And as the layers slide over each other, what happened as a result? The metal will become a sheet here, as these layers are sliding over each other, but the layers does not break. So as you can see, one layer is sliding over the other. The layers does not break, and we call this material as a malleable. If the layers break, we call that as a brittle. So these are some general properties of the metals. Is it clear? The three properties of the metal, that metals usually have high melting and boiling point because of strong metallic bond or strong attraction between the positive ion and the free electron. They can conduct electricity, heat and electricity, because the ions can vibrate and the electron can travel from one place to another. As well as the layers can slide over each other. That's why the metals are malleable, or it can be hammered into shape. Any doubt till this point? Okay. Then what is the difference between a pure metal and an alloy? A pure metal, it is highly malleable because pure metal contains same size of ions in the lattice. So when same size ions are there, ions with the same size, so they can easily slide over each other. But what is alloy? Alloy means mixture of the metal. So when you have a alloy does not contain same size of ions in the lattice, as the size of the ions are not same. So it might contain different size of ions within the structure, and due to the presence of these different size of ions, what will happen? The alloys are harder. Alloys are not malleable. Alloys are harder. Why they are harder? Because of different size of the ions, the layers cannot slide over each other, as they will have more friction between them. So whenever you have a mixture of the metal, that will become harder. So pure metals which having a regular arrangement of rows and equal size of the positive ions. So because ions are arranged in a regular pattern, so layers can slide over each other. So pure metals are relatively soft or malleable. Whereas alloys, which are the mixture of the metal, consist of two or more different types of metals, and the size of the metal ions is different, or metal atom is different, and that cause distortion or distort the layer or affect the layer. And due to this distortion, the layers cannot slide over each other, move over each other, and as a result it will become hard, or it become harder than the pure metal. So if I say we have alloy, two alloys are there, like or we have pure iron and we have high carbon steel. The pure iron, it contain iron only, whereas high carbon steel, it contain iron and carbon. Which one you think will be harder, pure iron or high carbon steel? Which one you think will be hard or less malleable? Yeah, that's right, high carbon steel, because high carbon steel contain two different types of atoms, so their size will be different. So high carbon steel will be harder, and low carbon or pure iron will be softer, or we can also say malleable. So increasing the amount or number of the impurities, the iron will become harder, or alloys will become harder. Then this is a comparison between the metal, non-metal, and metalloid. So metals, they have a shiny surface, or luster is there. Non-metal, there is no luster. Metalloid, what are metalloids? Metalloids, some of the properties resemble with the metal, and some of their properties resemble with non-metal. So metals are good conductor of heat, non-metals are poor conductor, and there are fair conductor, like small quantity can be conducted. In terms of electricity, metals are good, non-metals are poor, and metalloids are fair. Metals are malleable, means when we can hammer them into shape. Non-metals are not malleable, they are brittle, because opposite of, like if object is malleable, then opposite will be brittle. Brittle means when we apply the force, the object can break easily. Like glass is a brittle material. When you apply the force, the glass, you can easily break the glass, so it turned to be a brittle material. Whereas metalloids also, they are malleable. Ductile means you can make wires, you can stretch them into wire, because the layers can slide, so we can also make the wires. So malleable means we hammer into shape or hammering into sheet, and ductile means we can stretch them into wire, or we can make the wires. Non-metals are not ductile, metalloids are also ductile. Metals have high density, non-metals have low density, and metalloids, they're usually solid, so they have moderate density. Metals, high melting point, low melting point, and metalloids, depending on, because some of the metalloids have high melting point, and some of the metalloids have low melting point. So there's no fix. That's why it is not written here. Yeah, what is the meaning of ductile and malleable? The term malleable means you hammer into shape. Like example, there is an object, okay? This is example a metal. And when you use a hammer, by using the hammer, you can make or into sheets or thin sheet, what we call that as malleable. But what is ductile? Ductile means you can stretch them into wire. Like example, this is a metal. By applying a force, you can draw them into wire. Like you make them thin and make a wire. So if you are hammering and making a sheet, we call malleable. But if you are stretching them and making a wire, we call that as ductile. So that is the smaller difference is there between malleable and ductile. So ductile means stretch them into wire, malleable means hammer them into sheet. So general properties, chemical properties of the metal generally tend to lose electron, where non-metal tend to gain electron, and metals, their oxides are usually basic or amphoteric, whereas non-metal oxides are either generally a neutral, but it can be acidic. And corrode easily, corrosion, later in the chapter we'll discuss what is corrosion. Is it clear this part? Any question on this slide or from this slide? Then the physical and chemical properties, when we compare the transition element with group 1, physical properties, transition metal in the periodic table, when you see the periodic table, this part which is not placed in a specific group, we call them as transition elements. So when we compare the properties of the transition element, the physical and chemical properties of these transition elements with group 1 or alkali metals, transition metals are also known as the typical metals. So they are much harder. They have high tensile strength. What is the meaning of high tensile strength? Means you need more force to break them. If you need more force to break them, it means high tensile strength. They have high density, high melting at a boiling point, and many of their compounds are colored. What are chemical properties? Transition elements are less reactive compared to group 1. They have excellent corrosion resistance. But what is the concept of corrosion? Like with the passage of the time, if you leave, like example, a piece of iron outside for maybe like 3 months or 1 year, you will find that there is a layer of rust on the surface of iron. What we call this process, we call that as a corrosion. So most of the transition element, they resist corrosion, they don't rust. Few of them rust. Iron is a transition, it can rust, but most of them resist corrosion. They have variable oxidation number, that's why they're not placed in a specific group. Like group 1 is always +1, but for transition, it can be +1, +2, +3, maximum to +7. So they have variable oxidation number. Their compounds can be used as a catalyst as well. So them or their compound, like I can use iron as a catalyst. I can also use a compound of iron as a catalyst. A catalyst is a substance which alter or change the rate of the reaction without chemically used up. And some are strong magnetic materials as well. Then there are different types of alloys. You don't have to learn this percentage part. You don't have to memorize this part. This is just information. Like different types of alloys are there. If you have a solder, it is a mixture of tin and lead and it is used for wires and pipes. This is just an information. You don't have to memorize. A brass is there, which is an alloy of copper and zinc. You have to learn about brass specifically. And It is used for taps, for hose, pipes, fitting. Bronze is there, which is a mixture of copper and tin, used in ornaments, bell, bearings. Low carbon steel is there, which contains small proportion of a carbon, generally used for car bodies. Hard steel or high carbon steel, it is used for blades or drills. Stainless steel, maybe you have seen lot of crockery, the cutlery, sorry, not crockery, is made up of stainless steel. Like example, knives are there, forks are there, spoon, mostly stainless steel. Even the watches you will find there, it's also there stainless steel because it resists corrosion. So it resists corrosion, so it can be used for many purpose. Alnico is there, which is a mixture of iron, aluminium, nickel, and cobalt, which is used for making the magnets. So these are just examples of different alloys and their uses. Then the second topic is about the reactivity series of the metal. So it is the same thing what you have studied in the beginning about the electrolysis chapter. We started this reactivity series. So you should be able to mention the elements in terms of their reactivity. So that reactivity series include potassium, sodium, calcium, magnesium. That is please, send, cat, monkey, and zebra in large, high cage. But hydrogen is not the metal, so I'm not writing hydrogen here. Make sure fetch logged. So, but it is important that you should know the position of two elements. Number one, calcium. Number one, carbon. So carbon is there between aluminium and zinc. This is the position of a carbon. So carbon is more reactive than any of the elements which are below this line. And same thing, you should know the position of hydrogen. So hydrogen is there between a lead and a copper. And hydrogen also, it's more reactive than elements which are below. So as we go down in this series, what we observe the reactivity decreases. And always remember, the more reactive metal displaces the will displace the less reactive metal from its compound. So more reactive metal displaces the less reactive metal from its compound. So if I say I have calcium oxide and I add, or example, I have magnesium oxide and I add calcium. So we know calcium is more reactive. So the more reactive, as we see the reactivity series, calcium is above. So it can displace or it can knock out, and metal will knock out the metal, and the non-metal will knock out the non-metal, because calcium is a metal. So it will displace the metal or the first part, and as a result, what it will form? It will form calcium oxide. Magnesium is knocked out or removed. So as a result, what it will form? It will form calcium oxide plus magnesium. But if we try to repeat other way around, like example, if we have calcium oxide and we put magnesium, because the magnesium, as you can see, it is below calcium. So magnesium is not able to displace calcium from its compound. That's why there will be no reaction. So the reaction, the occurrence of a reaction, or whether reaction happen or occur, depends on the position of the element in the reactivity. So always the more reactive metal displaces the less reactive metal from its compound. So using the reactivity series, we should be able to classify these elements, their reaction with water, their reaction with acid, and their reaction with oxygen. So this is the reactivity series which we already have discussed. This is a very important table. You have to learn this table because in exam they ask to either state what you will observe or what will happen. So we'll learn each part separately. The table is all together, but we'll discuss each part separately. First, the elements are arranged in terms of their reactivity. You can see we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and then below is the platinum. First, when we check their reaction with air, because air contains oxygen, so basically it can be reaction with air or it can be reaction with oxygen. So what we observe, because the more reactive metal, they react faster. So potassium and sodium, they burn vigorously to form a metal oxide. So when potassium react with oxygen, it will form potassium oxide. So potassium plus oxygen. Now what is the formula? Potassium oxide compound formula should be correct because the potassium belongs to group 1. So it is plus 1 and oxygen belongs to group 6. So it is minus 2. So potassium oxide will be K2O. First, we always write the formula, complete a formula, and then we balance the equation. So to balance, we have 2 potassium, so I should put 2 potassium is balanced. Or when I try to balance oxygen, I put 2 oxygen is balanced. Then 4 potassium are there, so I put 4, so potassium is also balanced. So when potassium react with oxygen, it gives potassium oxide. Vigorous reaction or very fast reaction is there, or explosive reaction you can also say. Then calcium, magnesium, aluminium, zinc, and iron. They burn with a decreasing vigorously, like decreasing vigor, and down the series to form a metal oxide. So when calcium react with oxygen, it gives calcium oxide. When magnesium react with oxygen, it gives magnesium oxide. Zinc react with oxygen, it gives zinc oxide. But the reaction is slower. Like calcium react much faster with oxygen as compared to zinc. From lead, copper, and mercury, they react slowly to form oxide layer. So what is the difference here between these two reactions? So if you have a piece of copper, like example, say this is a copper. So when copper react with oxygen, not all of the copper turn into copper oxide. What happened? Only the surface will turn into copper oxide because it is a less reactive metal. So only at the surface the copper oxide will form. This gray shade is representing like copper react with oxygen. It forms copper oxide, which is a black solid. So when the surface get copper oxide, further no more reaction occur. It will stop. But for other metals, like if we have a piece of magnesium or piece of calcium, so when they react with oxygen, as a result, when calcium plus oxygen, the whole substance will turn into calcium oxide. All the particles of calcium mix with oxygen to give calcium oxide. But in case of lead, copper, mercury, only at the surface the oxide is formed, like surface reacted with oxygen, form oxide, and then the reaction stops. And silver and gold are not reacting with air. Is it clear? The first part, the reaction of these metal with air. Any doubt till this point? When potassium and sodium are there, they react vigorously. Vigorously means they react very fast. So when potassium plus oxygen, it will give potassium oxide. Then the second one is a reaction with water. So when we compare their reaction with water, in a reaction with water, some of them can react with both cold water. Cold water means water at room temperature. Some of them can react with water, cold water as well as steam, and some of them can only react with steam. So what will happen? What will be the result? When these metals are mixed with water, cold water. So potassium, sodium and calcium, when they react with cold water, as a result what it will form, it will give metal hydroxide plus hydrogen gas is there. So potassium plus water, what will be the product? Potassium hydroxide. So what is the formula of potassium hydroxide? Potassium is group 1, so it should be +1, and hydroxide is -1. OH. So the formula of potassium hydroxide is QH. Plus hydrogen gas will be there. So whenever hydrogen gas, so we'll observe bubbles. Then we have to balance the equation. To balance the equation, we start with oxygen followed by hydrogen and at the last other element. So one oxygen is balanced. What about hydrogen? 2 plus 1, 3 hydrogen, and here we have 2. So if I put 2 here, hydrogen is 4 on the left hand side, so I need 4 hydrogen. 2 is already there, 2 plus 1. So now it will be 2 plus 2. So 2 hydrogen plus 2 hydrogen, 4 hydrogen on the left, 4 hydrogen on the right. So hydrogen is balanced, oxygen is also balanced. And what about potassium? 2 potassium are there, so we will put 2. So potassium is also balanced. So this equation is balanced in terms of potassium, hydrogen and oxygen. So whenever they react with water or cold water basically, or even if there is a steam, it will result in a formation of metal hydroxide plus hydrogen. How 4 is there on the left hand side? Because this 2 multiplied by 2, this is 2 and multiplied by 2, that make 4 hydrogen. And this is 2, this 2 is with hydrogen as well, this 2 is with oxygen, and this is with potassium. So 2 hydrogen plus 2 hydrogen makes 4 hydrogen. So this equation is balanced. 4 hydrogen on the left, 4 hydrogen on the right. How 4 hydrogen on the right hand side? This 2 hydrogen plus 2 hydrogen will make 4 hydrogen. So when we add water as a result, as or normal water as a result, it will form a metal hydroxide plus hydrogen. So we'll see bubbles. But from magnesium till iron, they can only react with steam. So they don't react with cold water, they react with steam. And as a result, what will happen? It will form metal oxide. So example, if magnesium is reacted with steam, steam is also having a same formula. So magnesium reacted with steam or water, but at a high temperature, so steam is there or water vapors. So, but here it will form metal oxide. So it will form magnesium oxide plus hydrogen. So first three metals, when they are reacting, they are forming magnesium, oh sorry, metal hydroxide. But from magnesium till iron, they are forming metal oxide. And magnesium oxide formula, because magnesium belongs to group 2, so it is +2, and oxygen belongs to group 6, so -2. So we simplify the valency and cross multiply. Magnesium oxide will be MgO. So from magnesium till iron, whenever they react with steam, they produce metal oxide. Like if it was aluminium, react with steam, it will be aluminium oxide plus hydrogen. If zinc reacted with steam, zinc oxide plus hydrogen. Iron reacted with steam, it will be iron oxide plus hydrogen. And the metals such as lead, copper, mercury, silver, there is no reaction, so it does not react. So From potassium till calcium, they can react with both steam and cold water. But from magnesium till iron, they can only react with steam. And below iron, they cannot react. Is it clear, the reaction of these metal with water? And the last one is the reaction with acid. We already discussed this part. Whenever metal plus acid, it will give salt and hydrogen. So till iron, they can react with both concentrated and dilute acid. Dilute acid means contain more water. So from potassium till iron, they can react with both. But from lead and below, they can react with concentrated acid only. So till this point, they can react with the metal react with acid to give hydrogen. So when we write this table in simple form, so we have the reactivity series potassium, sodium, calcium, magnesium. So it is easy to remember if you learn the position of hydrogen here in this reactivity. So we know hydrogen is there between lead and copper. So this is the position of hydrogen. So the metal which are above, they can react with concentrated and dilute acids both. And the metals which are below, they can react with dilute acids only. Because hydrogen is more reactive than them, so they are not able to displace hydrogen. But here, these metal example, if I have potassium, which is a metal, I add hydrochloric acid, HCl. So potassium is more reactive than hydrogen. So potassium will displace this hydrogen. As a result, it will form potassium chloride plus hydrogen. But hydrogen, because it is a non-metal, when element form it exists, it always exists as a molecule. Here, the hydrogen was combined with chlorine, but as it exists as a free element, it should be a molecule. Then we have to balance the equation. There are two hydrogen on the right hand side, so we put 2. Hydrogen is balanced. 2 chlorine on the left hand side, so we put 2. Chlorine is also balanced. 2 potassium on the right hand side, so we put 2. Potassium is also balanced. So this equation is balanced in terms of hydrogen, chlorine, and potassium. So always the more reactive metal displaces the less reactive metal from its compound, and whenever element is there which is above hydrogen, whenever they react, what will be the result? So metal plus acid, this part we already discussed in the acid topic. So metal plus acid, what it will give? It will give salt plus hydrogen. That will be a product. The metals which are higher in the reactivity will give greater effort, like rate of formation of the hydrogen will be faster for them as compared to metals below in the reactivity. And the metals which are below lead, because they cannot react with dilute acid, in the lab we are using dilute acid, so we don't find their reaction very common in the lab. Is it clear how the metals are reacting with oxygen or air, with water, and with acids? Any doubt till this point? So this is a very important table. You have to learn this. Any question or doubt till this point?